My name is Luciana Carrion, and this is my presentation for Project 3. First, we're going to be reading analog voltage inputs from our Arduino. Our voltages will be read from the input pins and converted into a number system from 0 to 1023. Then we convert this voltage into resistance using the formula on the right. Then the Arduino converts resistance to temperature using the formula you see on the right. The temperature will be given in Kelvin, and using formulas we will convert it to Celsius and then Fahrenheit. Taking a closer look at our code, we have our variables being declared as an integer thermistor pin, integer initial voltage, float R1, float log R2, R2, T, TC, and TF, and our float C1, C2, and C3. Then we have our connecting colors to pins for LED outputs. Our blue color will be connected to pin 9, green to 10, and red to 11. Then we have a method where we'll input green, red, and blue color values to get a specific color for outputs for our RGB LED. Then we have our command for color outputs. Next we can see our voltage conversion, first to resistance, then to Kelvin temperature, then from Kelvin to Celsius and Fahrenheit. Afterwards, we see our temperature ranges for their corresponding LED colors. And finally, we see what would be printed on our monitor output. This will be what we will be testing for our temperature ranges. First, from 60 degrees and everything up, starting from rose, magenta, violet, blue, azure, cyan, aquamarine, green, chartreuse, yellow, orange, and finally red. This is almost all of the colors on our color wheel. You can see our RGB color method inputted for these specific colors and our temperature ranges for each one of them. On our breadboard, we can see our three 330 ohm resistors connected to each leg of the RGB. The fourth leg is connected to ground, and our 10k ohm resistor connected to our thermistor. All of them are connected to our Arduino board through jumper cables. We can see that our LED is rose. As we touch the cold spoon, our thermistor will be sensing the coldest temperature that we have for our range. Looking onto the serial monitor and taking the spoon off, we can see the thermistor is sensing warmer temperatures, and as a result, the colors of the RGB will change according to our ranges. It will go through the full amount of colors that we have listed, proving that our circuit and our code works. This is the end of my presentation. I hope you enjoyed.